Unit 4, Structures. Lesson 1, Data Classes. Upon completion of this lesson, you will be able to define the concept of data classes in Python, create a data class definition with fields, write code that imports and uses the data class Decorator, create an instance of data class, explain the difference between a data class and an instance, identify the fields of a data class, including their name and types. Write code that accesses the values and data class instance fields. Data classes. We have learned about 5 primitive types: Boolean, integer, float, string, and none. We can use these to represent many kinds of data, but they have a limitation since they are so simple and cannot be combined with each other. To increase our capabilities, we will learn about new category of types, which is composite types. Composite types are named because they are composed of other types. Unlike primitive types, the first kind of composite type we'll learn about is data class, a way to make new types that collect multiple values together in one place. Data classes are a data structure that let us combine other types together to make new type. You should not think of data class as a type itself. Instead, it's a way of creating new types. Or put another way, data classes are kind of type without being a type themselves. An example data class. Let's look at an example data class. First, you must import a decorator from the built-in Dataclasses module, one of the many built-in libraries that Python conveniently provides for us. Then we create a definition for the data class by writing the header and the body of the data class. The header requires the decorator, the class keyword, the name of the new data class, a colon. The body requires that we specify the fields, each on their own line. So required import from data classes, import data class. Definition: data class box with integer, lang integer. Once defined, we can create instances of the data class using the constructor function, which has the same name as the defined data class. Storing the result in a variable allows us to use the instance later, such as shown in the following example, where we print the myBox variable. Instance creation. myBox is assigned box with 5 and 10. Using the instance, print myBox. Let's try this. The variable box was used on line 2, but it was not given a value on the previous line. You cannot use a variable until it has been given a value. What happens if we okay, now it runs. Okay, now it has sense. Let's break down each part of this example further. Data class decorator. Perhaps the most confusing part of data classes is the decorator. The decorator is the data class annotation. The @ symbol that we see in front of the word data class is the syntax that makes this a decorator. Basically, The decorator adds extra functionality on top of classes. In this case, to make the classes into data classes. The decorated data classes are far more powerful and convenient than regular classes. Okay, there's a lot that can go wrong when using a decorator. You must import the data class decorator from the data classes module without including the add symbol. However, when you put the decorator above the class definition, you absolutely must include the add symbol. Messing up either part will prevent Python from understanding that you want to create a data class. From data classes, import data class. Add data class, class dog, pass. Unused variable. The class dog was given a definition on line 4, but was never used after that. Data class fields. Fields of a data class are the most useful part because they allow us to bundle up related data into a single place. Each field is like variable inside of the data class. The rules for naming fields are the same as the rules for naming variables. First, the name must have only letters, digits, and underscores. Second, the name must only begin with letters or underscores. The rules for specifying the type of fields are like the rules for specifying the type of function parameters, except instead of commas, each field is on its own line. From data classes, import data class, add data class, class dog, name, string, age integer, is fuzzy, boolean. How many fields are in the data class shown above? How many fields? What is a field? The field of a data class are the most useful part because they allow us to bundle up related data into a single place. 3, let's say. Correct. The 3 fields are name, age, and is fuzzy. Okay, so data class is something else than a function. The constructor function. Once a data class is defined, you can create any number of instances that represent concrete versions of the original data class. Instances of data class are created by calling the constructor function. The constructor is a special function created by the data class definition and given the same name. The similarity between defining a function and defining a data class is very strong. The similarity between calling a function and instantiating, creating an instance of the data class is even stronger. Each field of the data class definition corresponds to an argument for the constructor. The order and type of each field must match the order and type of each argument. From data classes, import data class. Add data class. Class dog name is no, it's not assigned. Name string, age integer is fuzzy bool. ADA is assigned dog. Ada Bart or Ada Bart. 4 and true. Okay, name is string. Yeah. How many arguments do you need for a constructor function of a data class with 5 fields? 5 arguments, perhaps. How many arguments do you need for a constructor function? Or 1, I would say 5 or 1. Let's go for 1. Each field will need a corresponding argument, then 5. Okay, each field will need a corresponding argument. Unnecessarily, I think unnecessarily, this might be tricky, because it is sometimes. Class versus instance. A very confusing concept is what a class represents compared to an instance of the class. A similar concept is the difference between a stencil and a drawing. Another similar concept is the difference between a recipe and a cake. In all these cases, one of these is an idea, something totally theoretical. The other is a concrete thing. Let us consider the box example from before. When you only look at the definition of the box, is it impossible to say what color a box is? You can generally say that the color of a box will be a string value, but there is no specific string value associated with the idea of a box. Instead, you would need to create an instance of a box to talk meaningfully about the color of that box. The concept of box does not have a color or length. You can create an instance using the constructor function that is red or blue, but the original box object itself does not inherently have a color. Data class, the pattern that is used as a base for instances. Instance, a specific concrete example of a class. So data class is a dog. Instances. So a dog could be this dog or that dog. Okay, I get it. So this is a data class. We have dogs, we have humans, and so and so. But different humans, different dogs. Accessing fields. One of the most critical parts of using an instance is to access its fields. The period and the name of the field are used to access those fields. Generally, you can think of a field as a variable that lives inside of an instance. In the code shown here, we access the name field of the dog, instance stored in ADA or ADA. A critical thing to understand, however, is that you can only access the fields of an instance, not a data class. In other words, you cannot try to access the fields of the dog data class, only the ADA instance. If you try changing the code, you will see that you get an error when you try to access dog name instead of ADA name. It's very important to understand the idea that the dog is not an abstract idea, while the ADA instance is a real concrete bit of data. Is an abstract idea. So a dog is an abstract idea. From data classes, import data class. Add data class. Class dog. Name string. Age integer. Is fuzzy boolean. ADA is assigned. Dog ADA BART for and true. Print ADA's name is ADA name. ADA.name. Okay. ADA.name. And why dot? Okay, because it has 3 fields. This data class has 3 fields, and one of them is name. Age is passive. There are many words that mean roughly the same thing when it comes to data classes. One concept that has many synonyms is the term field, which can be used interchangeably with attribute, property, and member. So field, attribute, property, member. We will use the terms field and attribute most often, although occasionally we will refer to properties or members. Which of the following will correctly access the age of the dog instance above? Above. We can only access to the other dog because that's already clear. Correct. The variable other is holding an instance of a dog, so we can access its age attribute. Fantastic. Tracing the data classes. The data stored in the data class is more complicated than the data stored in a simple variable. There are multiple pieces of data, the fields, all stored in a single object. Conceptually, we say that the data for an instance lives in an area of memory called the heap, as opposed to living in the stack that we learned about in Unit 3. The heap, what is that? Haufen. Der Haufen, okay. Heap is der Haufen. The heap is a special region of memory with many interesting properties that we will explore over time. Variables on the stack can hold reference to values on the heap. For now, we can use a stack heap diagram like the one below to visualize the relationship between the variables and data on the stack and the data on the heap. Okay. Ada is assigned dog, Ada Bart, for true. My dog's name is assigned Ada dot name, point name. Stack and heap. So global frame, it's Ada, it's variable. My dog's name, Ada Bart. Okay. And if we have heap, then we have dog instance age for fuzzy true name Ada Bart. In the previous stack heap diagram, you can see how the data classes are traced a little differently compared to regular primitive types of data. When the constructor is called, a new instance of data class is created. That instance is a special kind of value with multiple fields, which can be seen on the right-hand side of the diagram. When code accesses one of those fields, like on the second line, ada.name, the arrow is followed and the name field value is reached. That value is simple primitive string and so can be stored directly in the myDogsName variable. The ada variable points to the entire dog instance, unlike the myDogsName variable, which points to a simple primitive value. For now, we all need to do so. Keep track of the difference between primitive values stored in the stack and special instances stored on the heap. But eventually we will develop a deeper understanding of how data is laid out. In the stack heap diagram provided previously, what does the arrow represent? The variable ada is holding an instance of a dog data class. The adder function calls the dog constructor. No. The adder variable is equal to the string adder Bart. No. The variable adder is holding an instance of a dog data class. In this lesson, you learned about composite types, which are types that are composed of other types, unlike primitive types. One kind of composite types that you learned about is data class, which is a way to make new types that collect multiple values together in one place. Data class is not a type itself, but a way of creating new types. To define a data class, you need to use Decorator, class keyword, a name, a colon, and a colon. The body of the data class specifies the fields, each on their own line. The fields are like variables inside the data class, and they have names and types. To create instances of data class, you need to use the constructor function, which has the same name as a data class. Instances are concrete examples of the data class, and they have specific values for each field. The order and type of each field must match the order and type of each argument for the constructor function. You also learned the difference between a data class and an instance using analogies such as stencil and a drawing, or a recipe and cake. The data class is an abstract idea, while an instance is a real thing. You can only access the fields of an instance, not a data class. You also learned some synonyms for the terms fields, such as attribute, property, and member. Finally, you learned how to use a stack chip diagram to visualize the relationship between the variables and data on the stack and the data on the chip. The stack is where simple variables live, while the chip is where complex instances live. Variables on the stack can hold references to values on the chip. To access a field of an instance, you follow the arrow from the variable to the instance, and then to the field. This is how you can use composite types to store and manipulate more complex data in Python.